Hey, Vlad here, devinside.com, and welcome to the 7th video in the Scala playlist. Now, I made a video in the past in which I claimed that programming is all about assignments, if expressions, and loops. Now, we already talked about assignments and if expressions, alright, but what about loops? And what do loops have to do with recursion? Well, recursion is a term when a subroutine calls itself, and if it does this multiple times, then you basically have a loop. Now, there are a few things that I want to mention before we start with this video. Now, recursion is a very complicated topic and beginners usually hate it. So if you don't understand this video, watch it a few times, okay? And the second thing that I'm going to mention is that it took me more than 9 hours to prepare this video. So it might get like really long. So if you see something like part 1 in the video, then it means that somewhere in the middle of it, I had to cut it, okay? And upload it separately. As always, we're in Ubuntu and we have Sublime on the left and the terminal on the right, and it's in this continuous loop where it just runs whatever we have over here. So I just said that recursion is when a subroutine calls itself. So remember we had that def method equals method, right? And let's just call it, and let's see what happens. The first thing that should happen is that Scala will complain. It says recursive method called method needs result type. Okay, so let's specify result type. Let's say that it's going to be a string. Okay, so now it's fine. Okay, the thing is that Scala has a so-called local type inference. So in order to figure out the type of this, it needs to know the type of that, right? So it goes in and says, okay, so what's the type of the method? And if you don't specify that it's a string or something else, then it basically does not know what this is, right? And because it doesn't know what that is, it can't know what this is. So it's in this sort of infinite loop, and it can't figure it out. So basically, every time we have a recursive function, then we have to help the compiler out, right? So we have to specify the type. Okay. Now, I need you to notice that what we see over here is this first print line, right? But we don't see this second print line. And it's happening because the compiler is sort of stuck, right? Sorry, not the compiler. So the JVM is sort of stuck calling the same method over and over and over and over again. So this is what's known as an infinite loop. And you can always notice an infinite loop based on the CPU, right? So this is my CPU and it's running right now, right? So if I just kill SPT, you should see this thing going down. See, it's going down. So let me start SPT again. Okay, and notice also that because it got stuck over here, it never got over here, right? So it never showed this the second line of hyphens. Okay, so before we continue, we are going to produce a situation like this sometimes, right? Quite a few times in this video, sometimes on purpose, sometimes not on purpose, and I don't want to kill SPT every time, and therefore there's a very awesome plugin called SPT revolver that we're going to be using. So if we go to this URL, github.com/spray/SPT revolver, then we see this plugin, right? And the way we install it is by having a file called plugins.spt in the project subfolder, and in fact it doesn't have to be called plugins, it just has to have an extension of SPT. So let's do this first. Let's go back to Sublime. Let's see our project structure, and in fact it already has a folder called project, and it contains only one file called build.properties where we specify the version of SPT itself. So let's create another file. Let's call it plugins. What's happening? Plugins.spt. Now, as I already said, it doesn't have to be called plugins. It's just that the extension has to absolutely be .spt, and it has to be in this project folder, right? Notice that spt, when it's running, it also creates this empty subfolder. We can remove it, right? So so that you just see it a little bit better. Oh, sorry, did I remove the wrong one? Oh no, I didn't remove the wrong one. I just created the file in the wrong one. Okay, so let's close it. Okay, so hold on, project, new file, plugins.spt. All right, so it needs to be in this project folder, right? But as soon as we reload spt, which is basically the same thing as restarting spt, it's just gonna keep creating this this empty project folder over here. See, it's empty, right? So just ignore it for now. Okay, so The idea over here is that you create a bunch of .spt files, and one of them is going to be for plugins and the configuration of the plugins. The other one is going to be for the settings for the compiler, for example. The other one is going to be for the settings for the JVM and so on. So you can call them however you like. It just that they have to have the extension of .spt. Right. So let's go back to the page, and let's just copy this. So this is all that we need to do. We need to copy this line, and we need to put it into this plugin.spt file, right? And let me collapse it like this. So this is all that it says, right? So there's a way for SPT to find things online, and SPT is just going to download it. Now you're not going to see that it's downloading it for me, right? But if we say reload, it's going to notice that now it actually needs this plugin. You're not going to see that it. You see that it tries to find it, right? It tries to resolve it somewhere. No, you actually don't see it. So the thing is that I already have it. So my SPT already did download it while I was preparing for this video. So anyway, let's go back to our file. So what SPT revolver is doing, it's giving us a few more commands. Instead of saying run, right, or instead of saying ~run, it's giving us the command called restart. And restart is basically like run, right? But if your application is already running and it's stuck in an endless loop, for example, right, you can just type it again. You can just say restart, right? Hold up, restart. There we go. And now what it did is, so in the beginning it just said, okay, application Scala playlist not yet started, and now it started the application in the background. And now the second time we typed in restart, it stopped the application and then started it again. Okay, and we can also always see the status, right? So it says it's currently running. As you can see, based on my CPU, it's always running, right? And we can also do tilde restart, and we're gonna have a similar behavior as we had before was rerun. Now I don't like the fact that it uses like so many colors, because what it's designed for is to have multiple applications running at the same time and talking to each other. It was designed for a project called Spray, which is an HTTP client and server API. So it was probably used for tests and for very fast development. So what we're gonna do is we're not gonna have that. So we don't need all of these colors. So if we go to our build file, not the plugins.spt, to actually our build.spt, and if we add a line like this, let me just copy it over. re_colors colon equals revolver no colors. I'm sorry, I just copied something wrong. So this is all we need, right? So if we just do restop here, right, and we just reload SPT, then the next time we're going to do restart, it's just going to use less colors. So it's still going to use the yellow color over here, right? But every time we save, and it's just going to restart it, everything else is going to be white. Okay. So the other cool thing is that we can also just say 10 here, right? And it's just going to kill it, and it's going to run it. And because now there's no endless loop. And I'm sorry, it needs a string. Whoops, how did I do that? Need the string 10. Right, so now it's just gonna rerun, and everything's gonna be fine, and it's gonna look like this. So a bunch of hyphens, 10 hyphens, and it finished with exit code 0. Right. So the next thing that we're gonna do is we're gonna have a bit less hyphens. Right. So let's have 30 hyphens. Right, and also we don't really need that. Okay. Right. So this is what we want to have, and let's go back to recursion. Let's call this method again. Right. So the next thing that we're gonna have is the compiler tries to help us out, right? It says method does nothing other than call it a recursive. We've already seen that before. So let's do this. Why is it indented like that? That's what I want to have. Okay. So we also want to have a print line and method. Okay. So now what we should see this print line all the time. And notice that the CPU is going even further. And also notice that sometimes over here, you're going to see that it's going to flash a little. And the thing is that printing out things on the console cannot happen as fast as just calling yourself all the time. Okay, so this is also why it requires that much CPU. So I don't want to have that, right? But I also don't want to have a warning. So what I'm going to do is I'm just going to have a val over here, while leave me alone equals true. Okay, so now I don't see the print line. Okay, my CPU is sort of a little bit more down. Okay, and yeah, and the application is running over here. Let me save that. So you see this nasty output because it has to kill the application in a weird way. Okay. Just a few notes about SPT Revolver before we continue. So it's called like this because it's designed for very fast development, fast as a revolver. And what it's doing is it forks a JVM inside of SPT. So what it's doing is it creates like a separate process and it monitors it. So there are like a bunch of things running, and every time we make a change, it just kills the other JVM and creates a new one. So we don't have to control C and then kill the whole SPT. So this is how it works, right? So it forks. The term is forking, right? So it forks a JVM. All right, so we obviously don't want to have an infinite loop, right? So what is causing the infinite loop? Well, we always call method, right? So what we want to have is that sometimes we don't want to call method, and sometimes we just want to be done, right? So we want to have something like if something, then call the method. Otherwise, just say done. Right, and so what's happening right now is something like this, right? So if true, it just keeps calling itself, right? But sometimes we want it to be false, right? And we want to stop calling itself, right? We just want to return done as over here. So how are we going to do this? Well, we need some sort of external force. In my example, we're just going to use the current time, right? So when a few seconds are going to pass, just stop calling itself, okay? So Scala is fully compatible with Java, and the way you obtain the current time in Java, since recently, is like this. So we're just going to say get current time equals Java time local date time dot now. And in fact, before we continue, let's just play with this a little bit. Let's just not do that. Okay, let's just print out get current time. Let's see. All right, so this is the current time. So it's 30th of December 2017. Yes, tomorrow is the New Year's, and it's 16:27, and we got the seconds and we get the milliseconds as well. So what I want to have is that every 0 second, 5 second, or 10 second, or 15, 20, 25, and so on, it should stop running. And if it's in between, that it should keep calling the method. Okay. So the way we're gonna do is first we're gonna rename this into get current second. Okay. And over here we're just gonna say get second. And let's print it out. So just see 39. And I'm going to run it again. We see 42. I'm going to run it again. We see 44. A bit later in the video, we're going to talk about threads. And remember, I mentioned that thing. I don't remember in which video actually, but you can sort of pause the current thread for a while, and for how long you give it in milliseconds. So if you're going to stop it for a second and just going to print it out again, right? And just going to stop it for a second again, and just going to print it out again. Right, then we should see a print line every second, right? We see 21, 22, 23. Now, if we didn't have that, right, CPU is much faster than doing one instruction per second, right? So it does millions and millions of instructions per second, right? So we see the same second printed out a few times, even though it's a def, right? Even though we're getting it all the time, it's a new value, okay? Let's revert all that. So we don't need this whole get current second. We just need our example, okay? This thing. Okay, so we're back to the endless loop, but we're not, because we're not using this get current second thing. Okay, so let's actually use it. So the way we use it is in the if expression. We're gonna say if the rest division by 5, right? So this symbol, this percentage symbol, is a common operator used in programming for the modulo operation, and modulo operation is the division without rest. So it gives you the rest. Right, so if this is not equal to 0, then it means then we're somewhere between 0 and 5, right? Somewhere between 5 and 10, somewhere between 10 and 15, right? So if we're there, then just keep calling the method. Otherwise, just say that we're done, and let's see what's going to happen. Right, so first of all, we don't really need this thing anymore because more things are already happening, right? So we see in it's waiting, and then done, right? And now again, waiting, and now done. So let's actually have a print line. Let's have a print line over here. Let's have a print line get current second, and because it's a def, right? Even though it's really, really fast, I actually want to have it in a val. Let's freeze the current second, right? Let's have val current second equals get current second, and let's just use that one instead. Right? So what we're going to see now is we have the same second printed out quite a few times, right? And then it should stop. There we go. There we go. So we had 43, we've seen it like a bunch of times, and then we've seen 44 a bunch of times, and now when it came to 45, it stopped. Okay, it's done. Now, this is an example that I chose just for educational purposes. Usually, when you use recursion, you don't want to just do randomly stop. You know, you want to have full control of stopping. So what we're gonna have is we're gonna manage this state ourselves, right? So somewhere over here, right? Even though it's def, somewhere over there is a var that keeps track of the current second. In fact, it's happening on a different thread. You know, we paused the current thread like a few seconds ago, and on a different thread, things were happening. We're going to talk about threads a bit later in the video, so don't worry if you don't understand what I just said, right? But basically, something else was taking care of managing this state for us, right? So in our example, in the next example, we're gonna do it ourselves. So we're just sort of gonna fake it. So we're going to have a var ourselves, right? And instead of calling this thing, we're just going to say 1, okay? The rest stays the same. So now if we run this thing, it should give us 1, 1, 1, 1, 1, 1, 1, 1, 1, right? Because we forgot to actually manage this state, because, you know, nothing on a different thread is changing this var. So we're going to have to change this var. And the way we change the var is by doing this. Get current second +1. And this is a common mistake that beginners are doing, because in fact it didn't change anything, because well, we added 1 to the get current second, but we didn't change the var, right? So we also need to change the var. We need to do get current second equals whatever the value of get current second currently is +1. Okay, so now it should actually do 1 2 3 4 and then print out done. Also note that there is a shorter syntax for this. So instead of saying that and having a mistake like that, we can just add an equal sign over here, and it's going to do exactly the same thing as over here, right? So this is what we're actually going to have. So this is a very common syntax. And in fact, some languages like C++, and this is where the name comes from, is they do this, ++. And this is where the name C++ is coming, right? Okay, but in Scala, this is not possible, by the way. All right, so this is not going to compile. Let's see this. Yeah, so it's not a member of an integer. Okay, so let's have that. Everything is working again. So if we start with 1, then it's going to be done, right? But if you're going to give it a 0, then it's just going to go straight to done. If you're going to give it a 5, it's going to go straight to done. If you're going to give it a 10, it's going to go straight to done, right? Because of this thing. We're going to talk, by the way, about this and about that in the next video. I believe it's the next video. Yeah. So let's go back to 1 and go back to our regular example. All right, you gotta love revolver. I gotta say, SPT revolver is awesome. You know, endless loops and whatnot. It just freaking works. Doesn't die. It's cool. All right, so let's look at what we have here. So first of all, we don't have seconds anymore, right? So in fact, what we're doing is we're sort of counting the iterations, right? Like how many times did we call ourselves, right? So let's rename this into get current iteration, right? Same thing. And now that thing is not called current second, it's called current iteration. Right? And also notice that because we have full control of this var, right? So it's not a def anymore and some other thread changes it behind our backs. It's a var, so we have full control of it. So there's no need to get it because we're using it twice, right? So there's sort of no need to freeze it, right? So what we're going to do is, this is actually not get current iteration. This is actually current iteration. And now over here, we're saying, okay, current iteration is current iteration, so we just don't really need it, so we're just going to remove it, all right? So this is what we have. The next thing that I want to do is I want to have different versions of the same algorithm, right? So I want to have different code that is doing exactly the same thing. This is also called refactoring, by the way. So I want to have method 2 and show you a different implementation of this. But before we do that, we should keep this var as close as possible. Right, so vars and managing state is complicated as it is. So let's keep a close eye on it, right? So let's keep it closer. We however, and by the way, let me inline that, okay? However, we can't just put it in over here, right? So because this basically ruins everything, right? So we're gonna have a deeper discussion a bit later in the video about what exactly is happening behind the scenes, but we can't have it over there. So. So what are we going to do then? How are we going to solve this problem? Well, when in doubt, just have another scope around, okay? So first of all, I see an empty line here that I don't need, okay? So what we're gonna do is, the first thing that we're gonna do is, instead of having a method here, right, we're gonna call it loop. We're just gonna call it loop, okay? And what we're gonna do now is, we're gonna leave the print line alone, but we're gonna take all of this, right? And we're just gonna surround it with another scope. Okay, so it's going to be closed here, and what we're going to have here is def method, right, as we had before. So we just have a scope around, and it's going to be like this, right? So now everything looks the same, sort of, right? What did I forget? Found unit, required string, la la la. Oh yeah, we have to also call loop over here. There we go. Right. So now we have the same thing. So if it's 0. It's going to be just done, and if it's going to be 1, then it's going to do the same thing. So all we did was we renamed method to loop, and we just had another scope around it, and now this scope is a method, right? So we're still calling method. And by the way, notice that now method is not calling itself, loop is calling itself, okay? And because of that, we don't need the return type. Now I'm gonna leave the return type there, right? But just so you know, right, you don't need the type. So now Scala is capable of reconstructing the type. However, over here it's not, right, because this is still a recursive method, okay? All right, so now we can have the next implementation of method, okay? So what we're gonna have here is, I'm just gonna copy that. In fact, I'm not gonna copy that. I'm just gonna duplicate it and bring it down over here, right? So what we wanna have is we wanna have method 2, right, that somehow produces a string, right? And we're just gonna call method 2. Okay, this is what we wanna have. Right, and how we're going to do it is, yeah, you learned in the previous episode about subroutines, right? About a different way of binding, right? So before we knew just def x equals 10, and we know that the value of 10 is bound to x, and now we also learned that we can also have a parameter, right? A parameter of a subroutine, which is a different binding, right? So we have def method, and it takes an int, right? So whenever it doesn't matter what it's doing, right? So later when we call method with, I don't know, with 20, then this 20 is also bound to that x. Right? So this is a different way of binding, and this is exactly what we're going to do over here. So the method 2 is going to look very similar to method 1, right? In fact, maybe let's just call it method 1. Yeah, we're going to have method 1 and we're going to have method 2. So method 2 is going to be very, very similar, but instead of binding of this variable like this, we're just going to have a parameter for loop. In fact, let me just copy everything from here, right? And put it over here. Right, so now they look the same. I'm not sure why Sublime did that. There we go. So now they look the same. So method 2 and method 1, they're doing the same thing, okay? But the code also looks the same. So what we're gonna do now is, look at this. So instead of having this current iteration equals 1, we're gonna put a 1 over here, right, into loop, right? And therefore loop is going to need this parameter, right? So we're going to put a parameter list over here, right? We're going to put the current iteration over here, and we're going to have to say that it's an integer, right? And we're not going to have this thing, right? And because we don't have this thing, we can't increment this. By the way, the parameters that are going into subroutine, they're vals automatically, so we can't do that. In fact, if we do that, maybe the compiler is going to tell us, yeah, it's going to say expression doesn't convert to assignment because receiver is not assignable, right? So it's a val, right? But we actually don't need that. We actually don't need the whole thing, because this whole thing is going to go in as a parameter to loop without the equal sign, obviously, right? And we're just going to have that. And there we go, the same thing, 1, 2, 3, 4. And if we start with a 0, it's going to be just done. If we're just going to start with a 5, it's going to be just done. And so on. Let's revert back to 1. So now I'm going to scroll up so that you see both of them on the same screen, right? So that you can compare them and take a look at it, right? Pause the video, take a look at it, play with this on on your local computer, because otherwise you're just going to forget it. Okay, it's really important that you understand this whole thing. So take your time to understand it. Recursion is a very complicated topic. Beginners really hate it. The next part of this video is what is actually happening behind the scene, and this is where this thread thing is coming in. So remember, just a few minutes ago we did this thread.sleep thing. So what is happening is that when a program is running, you have a process, right? And if you have two programs running, then you have two processes, right? But inside of a process, what is happening inside of every program, you have this thread, right? And this thread is just running subroutines one at a time, right? And if you have multiple threads, then a program can do sort of multiple things at the same time. It sort of looks like it. In fact, let me go into Windows over here. I'm just going to say Task Manager, right? And I'm going to go to, I believe, Performance, right? And over here we see, okay, so I have 190 applications running, 190 processes, and this is how many threads I have, right? Anyway, this is just a bit of a sidetrack. So in order to understand what a thread is, in fact, we're not going to talk about threads too much. We're going to talk about what is inside of the thread. So inside of every thread, there is this thing called a stack. And all we need to understand for today is how a stack works. Now, a stack is just a synonym for a pile. So imagine if you have your table, and on your table you have a pile of papers, right? So if you're looking for papers, you can just look like crazy and put one take one from the middle, right? And also, if you're putting something in this pile, you can just take a paper and shove it somewhere in the middle, right? But the fastest way to take something from this pile is to take something from the top, and also the fastest way to put something on the pile is to put it on the top, right? So in computer science, when people are talking about a stack, they're talking about a very, very specific behavior. So it's not like in real life where you can just shove something in the middle. In computer science, a stack is something that you can only put things on top, and also you can only take things from the top. Okay, and in computer science, it's called when you're putting something on the stack, you're saying you're pushing it on the stack. Sorry, and when you're taking something from the stack, you're saying you pop the stack, right? So you push and you pop. It is also sometimes referred to as LIFO or LIFO data structure, and it stands for last in, first out, because the last element that you put on the top is going to be the first one that you're gonna pop. So what does this have to do with programming, and what does it have to do with Scala? Well, there are many ways of implementing subroutines, but the most common way is to implement it as a stack machine. So instead of having actual registers like a typical CPU would have, the JVM and Java and Scala, they have a stack of subroutines, right? And I'm gonna draw you a little picture of what is actually happening, right? So let me collapse that thing for a bit, right? So in every stack frame, right? They're called frames. You have the subroutine. So when an application is running, the stack is sort of grows and shrinks and grows and shrinks, right? So let's do it for this application for just for a little bit. So the first thing is happening is that this main gets pushed on the stack. So I'm just gonna do comments here, right? So I'm just gonna say main, right? So this is like a virtual representation of the stack. Okay, so we have main, and the arguments that are coming is an empty array, right? So both the subroutine and the parameters of the subroutine, the arguments, are stored in the stack, right? And the next thing that is getting pushed is this print line over here, right? So it's going to be print line, right? And the arguments are the hyphen is a string. Whoops, I'm sorry. The hyphen is a string. Times 30, right? What is the next thing? Well, the next thing that is happening is this thing is actually an operation on its own, right? So it's just called like this, right? And it gets called with arguments, and the arguments are a hyphen, right? And a 30, right? And by the way, like usually, I'm not sure why I just saved the file. I don't need to rerun anything, right? So usually when people are drawing stacks, then they use a different representation. So they do something like this. Let me copy it because I already got it prepared over here. So usually that's what people do. So they just represent the time as in like this. So this is like the first step, second step, third step, and the fourth step, because computers are basically clocks, right? So there's something that says, okay, do the next thing, do the next thing, do the next thing. So at first we had the main, then the print line got pushed on the stack, then the arg got pushed on the stack, and then this got popped, right? So the stack had a depth. It's called a depth, by the way, the depth of 2, right? But I'm not gonna do it here. Because I just didn't have enough space. So let me actually revert that and also string sublime again, right? So let me open that thing, right? So I'm gonna collapse method 2, and I'm going to collapse method 1 for a bit. Right. So the next thing that is happening is this one, right? Print-line method. So let's put it down. So I'm just going to keep writing it at the top, right? So oh no, I actually can't, because this thing got popped, right? So what we're going to do here is, so this is sort of going to be our time, right? So this is what happened like at 0. And this is what happened at 1, and so on and so on. Well, it's actually not 0 and 1, but you know, like this is sort of like the next relevant step for our discussion, right? So the next thing that got pushed was this thing, right? So we got print line, and the args as method. Okay, so no, method 2. Okay, so let's go into method 2. Okay, so in method 2, let's collapse loop, and the first thing is happening is loop was 1. Okay, so let's do it here. So we're gonna have loop, and the arguments was 1. Okay, and then we're gonna open this, and we're gonna ignore all of this, right? So we're not gonna do this, and we're not gonna do this print line. The relevant thing is here, right? So the argument was over here, the argument was 1, right? So we're gonna have, so we have a 1 over here, right? And the next thing is gonna happen is it's gonna call loop was 1 plus 1, so it's gonna call loop was 2, right? So I'm just gonna do this, right? And then it's gonna keep doing that, right? Was a 3. It's gonna keep doing that, was a 4. It's gonna keep doing that, was a 5. And then when it's going to call it was a 5, it's not going to end up here. It's going to end up here. It's going to be done, right? And then it's going to start removing those things, right? It's going to start doing this, right, and so on. Okay, but let's leave it like this for now. So now we see that in the first example, right, we were managing our memory ourselves, right? We had one thing, and we were just changing it all the time. In the second example, our memory gets managed by something else, right? By the stack itself, okay? There's a problem with it though, right? It did not use only one variable, it used all the 5 stack frames, right? So it consumed more memory, right? And memory, even though it's cheap these days, it's finite, right? So there's an end somewhere. And in order to demonstrate that, we're actually going to go back to Java. I will explain the reason why we're going back to Java in quite a few minutes in the video. As of right now, just bear with me. So we're just going to have another folder here called Java, right? And inside we're going to have a file called, let's call it Java main.java, right? So SPT can also compile Java if you have JDK installed, and we have installed it in the video number 2, I think. So we're going to have a public class Java main, because remember in Java it has to be called exactly the same as the file is called. And we're going to have a public static void main. We're going to string, whoops, come on, there we go, args. Right, and what we're going to do here is we're going to system out print line method, okay? And so remember that thing that we started with in Scala, we had method string equals method, okay? Well, we're gonna do a very similar thing in Java. In Java you can't have methods inside of methods, so we're just gonna have a public static, and it returns a string, and we need the parentheses, and we need this awkward syntax, and we need to return, oh, by the way, we have to give it a name, method, okay, and we're just going to return itself, okay, come on, going to return itself, right? So now if we save it, revolver or SPT, they both recognize, okay, now there's a different main method, so we're just going to do 2, right? So what's going to happen is that there is a problem, right? So in Scala, remember, it was just caught in this endless loop, right? Whereas in Java, something is exploding. What is happening is it kept calling itself too much, right? And then the stack grew so long, right? So it was so deep, then it just consumed all the memory that it had. Now it is possible to configure the JVM to just have more memory, but the problem is still not going to go away, right? Because over here nothing stops it from calling itself. So eventually it's still going to explode. It's called a stack overflow error. There's this whole concept of exceptions that I'm going to explain in a different episode. Well, basically we have a runtime, we have the JVM that makes sure that we're not going to do anything stupid. stupid, right? So whenever it notices something like that, what it's doing is it's basically wrapping a stack with some sort of like guards, right? So there are things that are always looking at the stack, and when weird things are happening, it throws a so-called exception, and when the exception is not handled, then and then the thread that is running on is going to die. And as of right now, we have only one thread, the main thread, and basically means that the whole JVM is going to die. So basically, the whole program is going to crash. So it finished with exit code 1 because it crashed. Okay, you don't see that it's actually throwing a Stack Overflow error because we need to scroll up like a lot, right? So in order to demonstrate that, instead of having this thing, we're just gonna throw, and we don't need these. Okay. So we're just gonna throw a new Stack Overflow error like that. Okay. Oh, and by the way, if you have multiple mains, you can go to build.spt, right? And you can just put in this thing. You can say main class in restart colon equals sum, and then you just give it a name. And in our case, let's say Java main, right? And then you would need to reload, and it just wouldn't ask. It just would always run this. So I don't want to have this, right? So I'm just gonna remove it again. All right. So as of right now, I'm just gonna say 2, right? So what happened now is it said exception thread main Java long Stack Overflow error. And by the way, if you don't do this without the revolver, right? So if we press enter and we're just gonna do run, and we're gonna say Java main, then you see like this Stack Overflow error. And in fact, let me maximize the terminal. So you see Stack Overflow error, and what you see here is exactly the stack. It's called a stack trace, right? So it shows, okay, so it called some native method, somewhere deep in the JVM, and then it called this one, and then it called that one, and then it called that one, and then eventually it called the main method, right? And it's in the file called java main.java at line 3. So if we go back to line 3, we're gonna see here, right? So it called main, and this is where it exploded. Okay. So what we also see here is that those exceptions that, again, we're going to have a separate video that talks about exceptions. So they're sort of hierarchical, right? So there can be an exception inside of exception, and so on and so on and so on. So what we have here is a runtime exception, and inside of it there's a Stack Overflow error, right? So SPT somehow caught it as well. So basically what I'm saying is that if the stack trace is very, very long, then in the end you won't even see this. Right, you're gonna see this. Like in the past, you would actually see, like at the very bottom, it would say, "Hey, it's a Stack Overflow error," right? And by the way, if you Google that, you're actually gonna find a page called stackoverflow.com. It's a website for questions and answers, and they're not paying me anything to say that. I'm just saying that if you wanna explore this thing a little bit, if you Google for Stack Overflow, you're probably not gonna end up at this. So Google something like Stack Overflow concept or Stack Overflow in Java or something like this. All right, before we continue, let me go back to this, right? Let's just say Java, okay, once, and let's do this. The very simplest way of doing recursion is this, right? So this is the simplest way of producing a Stack Overflow. Of course, I forgot a semicolon because Java has semicolons. Okay, so let's run this one, right? So this is a Stack Overflow. This is not happening in Scala, however, right? We've already seen this, but let's actually reproduce it. So let's duplicate this line and call it main2. So now SPT is not going to find it. It's gonna only find this one. And let's just gonna do exactly the same thing. We're just gonna call it main with arguments, right? So now, oh yeah, we had this 0 and 1. Let's remove all of that. Yeah, let's remove all of that, right? So now we're gonna do Java again, right? We're gonna save, and now we're gonna do Scala, and in Scala it's just caught up in this endless loop, right? So if we do re-status, right, it says it's currently running, and you see it based on my CPU. So Scala is doing something magical behind the scenes, and we're gonna see what it is actually doing behind the scenes to make it work. So as of right now, we're done with Java. So we're just gonna do restart with a tilde, and let's just go to the Java main and just comment it out, right? So that we don't have to choose the one that we want over here. Let's do this one. All right. Okay. So now we're back to normal, and we have our let's do this one now. Remove that. All right. So we're back to our main print line with method 1 and method 2, and we're calling method 2. Now, before we discuss how what Scala is doing, like what is this magic that is doing, a valid question would be, well, what are you going to do if you're not in Scala, right? So what are you going to do when you're in Java, right? And it turns out that Java has a very special keyword. And in fact, most programming languages have this keyword called while, right? That makes sure that for algorithms like this, it does not create this stack frame, right? So you don't have to use recursion, you can just use while, and you don't have to, you don't have to call yourself all the time, right? So one of the main design goals for Scala was to remain as Java compatible as possible, and also to be friendly for Java developers, because they were hoping that all the Java developers would jump ship, right? Didn't really happen, but this is a topic for another video, right? So Scala also has this while keyword. So you know what it's time for? It's time for method 3, right? So let's call method 3, and obviously it doesn't exist yet. And for method 3, I'm going to maximize Sublime, right? And I'm going to split it. Actually, let me close all the other tabs. I'm going to split the screen, right? And on the right, I'm going to open the same file, right? And I'm just going to scroll down a little, right? So we're going to copy method 1, right? And we're gonna put it under method 2, okay? Right. So see, I'm editing both files, right? So if I scroll up and I do something like this, we're editing both files, okay? So I copied the first method over here, and now I'm gonna call it method 3, right? And now everything should still work, right? Because now we're calling method 3, and the code for method 3 is exactly the same one as in method 1. And I'm doing that. Actually, let me show you. Okay, so see, it's actually working. Let me save it so that you're sure. Okay, it's actually working. Okay, let me maximize it again, and I'm gonna scroll down this exactly to method 1. And we're going to have a method 3 over here. And over here, we're going to have this while loop so that you just see both of them at the same level, so that you see that how very similar they actually are. All right, so the while loop looks exactly like an if expression, right? But instead of if, we're saying while, okay? And a while doesn't have an else, so we're just going to remove the else. And basically, when while is done, it's just going to return done, right? So loop is just going to return done. And because we have a while that is doing the loop for us, there is no need to call loop, right? And if I haven't forgotten anything, we're actually already done, right? So see, I just saved it and it ran again, right? So how we're going to do this? Let me see. Let's run it with 0. It's going to be done. Let's run it with 1. It's going to be done, right? And let's maximize it again and do that. Okay, and now because there's no recursion happening anymore, right? So we're just creating the staff and then we're calling it right away. Now there is no need to call it, right? So we already have a while loop. Why do we need our own, right? So we can just remove this and remove this curly brace, and now we're just gonna indent this thing over here, and we're not gonna need to call loop, right? So this is the method 3. This is the while loop, exactly the same thing. I forgot. I just pressed save and it ran, but you didn't see. So I'm just going to press save again, and then it's running. It's exactly the same thing, right? So let me maximize it again so that you can compare it, right, and play with it. So what we have here is 3 different ways of implementing the same thing, 3 different methods, right? Method 1, 2, 3, and you see them all in one screen, okay? And I'm just going to say it again. In Java, you're pretty much stuck with only this one, right? Because this one just consumes the stack, right? It just calls itself, right? And this one also just calls itself all the time, right? So it's just going to consume the stack. So if the number is really large, or if the condition is, if there's something wrong with the condition, or if it's just going to do this for way too much, the memory is just going to run out. Okay, so in Java you're pretty much stuck with this. In Scala you have a choice. We're going to discuss in a second what exactly is happening behind the scenes, right? Before we continue though, just a sidebar, a side note, you can't do this with functional literals. Remember, like in the previous video, I introduced the functional literals, and so instead of just defs, so functional literals, they can't actually call themselves because there's nothing to call, right? So there's no point of reference. This is why they're also sometimes called anonymous functions, and they're also called lambdas, because they come from this branch of computer science, or actually math, called lambda calculus. But we're not going to talk about them today. This is just a sidebar. All right, so let's talk about the magic that is happening behind the scenes. So what is happening behind the scenes is an optimization of tail recursive functions. So what are tail recursive functions? Well, if the last thing in a recursive function is either just a value, right? So if the function just returns a value, or if the last thing, like in every branch, or if it just calls itself, right? If it's the last thing, so if it's in the tail position, right? Because tail is in the back usually, right? So if the last thing, so if the recursive call is in the tail position, then a function is called tail recursive. And in Scala, if the function is tail recursive, then sometimes it can convert this algorithm, right? Or this algorithm into that. And as we already learned, this is very efficient. And by the way, on the CPU, this is converted into go-to instructions, right? The thing is that because of this, right, if it's not the last thing, right, if something else is happening, right, for example, we're returning a string here, right? So if it would be a loop plus I don't know, add something else to that string, right? So this all of a sudden, this would be the last thing that is happening, right? Because at the end, it would boil down to a go-to statement, right? There is no way for the go-to statement to come back, right? Because it just doesn't store this pointer where to go back, right? So in Scala, what you can do to be sure is you can add an annotation, right? So you can add an annotation to, let me collapse that. Okay, so you can add an annotation to a recursive function, right? You can say here at Scala, Scala.annotation.tailrec, right? And if the Scala cannot convert it into a while loop, it's just not going to compile. Actually, I haven't tried this when I was preparing, but this should not be tail recursive, right? Yes, exactly. So now it says it contains a recursive call not in the tail position. Let's remove that. Right? So this function is tail recursive, right? This function over there, right? It is also tail recursive, right? Everything is still fine. And the same thing was over here, and I haven't tried this in my preparation, but let's just try it, right? So we have main, and it's just going to call itself. By the way, if you don't call itself, it's also not going to compile because it's going to say, hey, you're using this annotation in a function that is not doing anything, right? So yeah, so see, it's still fine. It's a tail recursive function, right? And as I just said, if we just print line hello world, then it's not going to be, yeah, it's going to say, hey, it doesn't contain any recursive calls. Okay, so let me revert that thing to that. So yeah, so if you're a beginner, and obviously you're probably a beginner because you're watching my videos, you should all, when you're playing with tail recursive functions, always have this annotation just to make sure that you didn't make a mistake. All right, so I'm actually going to have to wrap it up, and we're going to have a part 2 of this video. Before I leave, let's sprinkle a little bit of computer science knowledge on this topic, right? Let me maximize Sublime again, like this, okay? And let me gonna do the split again and to have a while loop over here, right? So question number 1, is it always possible to convert a recursive algorithm into a while loop, or the same way a while loop into a recursive algorithm? And the answer is yes. So they're called isomorphic, right? So there's always a way. However, is it always possible to convert a while loop into a tail recursive function? Unfortunately not. However, there are algorithms, and there are actually quite a few of them, that when they're just written down in a sort of naive way, then they're not tail recursive. But you can actually implement them in such a way that they will become tail recursive, and then you can use this annotation, and then you will be sure that it was converted into a while loop. But as I already said in the beginning, in Java, and in fact in quite a few languages, you don't really have a choice because the tail calls are not optimized. Okay, all right, so this was part 1 of this video. I'm sorry that it got too long, and I'm really sure that we're not going to have a part 3, so it's just going to be this one and part 2, and part 2 is going to be shorter. In part 2, we're actually going to do something useful with recursion, because every example that I have used so far was just to count the iteration, right? Just to explain the concept. Okay, in the second part of the video, we're going to do something useful. Okay, all right, so I hope you like this part 1. Let's wait for part 2. Cheers.